Good morning. Welcome to our science class of class 8th. Today I am going to tell you about the chapter 4, that is metal and non-metal, in which I have already told you about the topics. Yesterday I have told you about the metals, their physical property and their chemical property. Now today I am going to start non-metals. Now today we are going to study about the non-metals, their physical property and their chemical properties. So today we are going to cover the rest of the topics of this chapter one by one. So firstly we will start with non-metals. Now let us know about that. What are non-metals? Non-metals, firstly we'll know that what is non-metal. Non-metal is an element that can form the negative ions by the gain of electrons. Yesterday I have told you about the metals. Metals are the elements that form the positive ion by losing the electrons. So they have the tendency to form the electropositive ions, but the non-metals have the tendency to form the negative ions by gaining the electrons. So the non-metals gains the electron to form the negative ions, and they have the valencies. The valencies of the non-metals are 4, 5, 6 or 7. So they have 4, 5, 6, 7 or 7 electrons in their valence cells. So there are about 22 non-metals we are knowing, and out of which 11 are gases, 1 is liquid, and remaining 10 are solids. There are some examples of non-metals also. For example, hydrogen, oxygen, carbon, sulfur, nitrogen. These are the examples of the non-metals. These are the examples of the non-metals in which hydrogen, oxygen, nitrogen, these are the examples that are found in gaseous state. But there is one exceptional case. There is one non-metal here also that is found in liquid state at the room temperature, and the name of that non-metal is bromine. So it is a type of non-metal that is found in liquid state at the room temperature. Now we are going to know about the physical property of the non-metal. So let us know about that. What are the physical property, in which the first one is their physical state. Now let us know about that. You are knowing well that non-metals exist in all the three states. They are found in solid state also, they are found in liquid state also, and they are found in gaseous state also. There are certain examples of non-metals such as iodine, silicon, carbon, phosphorus. Iodine, silicon, carbon and phosphorus are the non-metals which are found in solid state. Hydrogen, chlorine, oxygen, these are the examples of the non-metals that is found in gaseous state, and bromine is found in liquid state. So this is about the physical state of the non-metals. Next is about the hardness. We are knowing well the metals are generally hard, but there is some exceptional case that we have studied, that sodium and potassium are the example of the two soft metals, but non-metals are generally soft. Non-metals are generally soft, but there is one exception here, diamond. Diamond is a type of non-metal which is hardest, and it is the hardest substance known. So diamond is the hardest non-metal. Next is about their luster. They do not have metallic luster like that of metals. The metals have the luster, they have the luster, but here the non-metals generally do not have the metallic luster. For example, graphite and iodine. But here there is an exceptional case. Graphite and iodine are the examples of the non-metals that have the luster. Next is about the melting point and the boiling point. Non-metals usually have low melting point and low boiling point, but graphite is only the non-metal which have the high melting point, while silicon and boron have the high boiling point. Next is about the malleability. I have told you about that. What is malleability? The property, I have told you yesterday that the property by which the metals can be beaten into thin sheets. This property is known as malleability, and I have given you the example of gold and silver. These are the example of the best malleable metals But what here in case of non-metals? Non-metals are non-malleable, means that we are not able to convert it into thin sheets. They cannot be beaten into thin sheets, and when you hammered it, it gets break into pieces. So they are brittle. So this is about the non-metals. Next physical property is ductility. Ductility, I have told you that the non-metals in case of non-metals, the non-metals are non-ductile. As I have told you that metals are ductile, and I have told you that what is the property, what is this property? The property by which the metals can be drawn into wires. Means this property by which the metals can be drawn into wires is known as ductility, and I have told you the example of some metals like gold, silver, copper, iron. These are the example of the highly ductile metal, but this property is not possessed by the non-metals. So the non-metals are non-ductile and they break on stretching, and when you stretch it, it gets break down. So we can say that the non-metals are non-ductile. Next is about the tensile strength. I have told you that what is tensile strength. Tensile strength, they have means they can easily break, and they cannot bear the large weight. The non-metals have very low tensile strength, and they cannot hold the large weights, while in case of metals we have seen that they have the high tensile strength and they can hold the large weights. Tensile strength means they can hold the large weights. More tensile means they can hold the large weights, and high tensile means they can bear the large weights, and low tensile strength means they cannot bear the large weights. They cannot hold the large weights. Next is about the conductivity. Yesterday I have told you that metals are good conductor of heat and electricity, means that allow the heat and electricity to pass through it. I have given you the example of some best conductor of electricity. I have given you the example of copper, gold, silver, aluminum, tungsten, in which the silver is the best conductor of electricity. But here, what in case of non-metals? The non-metals generally are bad conductor, or we can say poor conductor of heat and electricity, means they do not allow the heat and electricity to pass through it. But there is only one exceptional case here. Graphite is only the non-metal which is a good conductor of electricity. We have seen that the lid of the pencil is made up of graphite, and when you touch any electrical appliances with having current, when you touch it with the lid of the pencil, it allows electricity to pass through it, because we are knowing well it is a type of non-metal and it is a good conductor of electricity. So this is only the exceptional case. In case of non-metals, metals are generally bad conductor, or we can say poor conductor, but this is only the exception, that is graphite, which is a good conductor of electricity. Now next property is about the sonorous. Yesterday we have discussed that what is this sonorous property. Sonorous means they produce a ringing sound when struck with hard materials. We have seen that metals are sonorous, means they produce a ringing sound when struck with hard materials, but there are some exceptional cases we have studied already, that sodium and potassium are the exception. They do not produce any kind of ringing sound when struck with hard objects. But the non-metals are non-sonorous. They do not produce any kind of ringing sound when struck with a hard object. Carbon and sulfur are the example of the non-sonorous non-metals. So this is about the physical property of the non-metals. Now we are going to study about the chemical property of the non-metal one by one. So first of all, we will start with the electronic configuration. Now electronic configuration, I have already told you the non-metals generally have 4, 5, 6 or 7 valence electrons in their outermost shell. So, and I have told you that they have the tendency to gain the electrons to form the negative ones. So this is one of the most characteristic property of the non-metals. Now second is about the reaction with oxygen. Now we are going to know that when the non-metals react with oxygen, what is formed. So we just know about that. which type of oxide is formed and what is the nature of that oxide that is formed after the reaction of the non-metal with the oxygen. Now the non-metals such as carbon, sulfur, phosphorus, that react with oxygen to form the non-metallic oxide. We have studied that the metal react with oxygen to form the metal oxide, and the nature of the metal oxide is what? It is basic in nature. But here what we have seen that the non-metals like carbon, sulfur, phosphorus, when they react with oxygen, they form the non-metallic oxide, and the nature of that non-metallic oxide is acidic. For example, there are some reaction given below here, in which first one shows that there is a reaction of carbon with oxygen, when carbon reacts with oxygen to form carbon dioxide. Next reaction, what? Sulfur reacts with oxygen to form sulfur dioxide, and when this sulfur dioxide dissolve in water, means that their reaction takes place with water, then there is a formation of acid. The name of that acid is sulfurous acid. Now we can also understand this with the help of one activity. In this activity, first of all, take a small amount of sulfur powder. Sulfur is non-metal. Take small amount of sulfur powder in a refrigerating spoon and heat it over a flame of a Bunsen burner. When the sulfur starts burning, with blue flame, introduce that refrigerating spoon into a glass jar and allow the sulfur to burn inside the glass jar. Now cover the glass jar with a lid in order to prevent the gas from escaping. Next is remove the spoon after all the sulfur has burned. When all the sulfur has burned, just remove that spoon from the glass jar and add a small quantity of water in the glass jar and replace the lid and shake the glass jar that the gas produced dissolve in water, so that when the sulfur gets burned, the gas is produced, and when we add the water to that, and after that, after adding the water, we just shake it properly. Due to shaking, that gas dissolves in water. Remove the lid and put a small quantity of that. We will get a solution in the glass jar. Now just take small quantity of that solution in a watch glass and now test that solution with the blue or red litmus paper. Then what we will observe in this case, when the sulfur burns in the presence of oxygen, a new substance is formed, that is sulfur dioxide, and on dissolving that sulfur dioxide in water, again the new substance is formed, that is sulfurous acid. So how we can check that this is the sulfurous acid? How we will observe that this is the sulfurous acid? Because when we check that solution, the solution with red litmus paper, when we put one drop of that solution on red litmus paper, the red litmus paper remains red. But when we put one drop of that solution on blue litmus paper, that blue litmus paper gets converted into, their color gets changed into red. So this activity shows that the oxide that is formed during this process, the nature of that oxide is acidic in nature. So the non-metals form the non-metallic oxide, and the nature of that non-metallic oxide is acidic. So with the help of this activity, we can easily understand that the nature of the non-metallic oxide is acidic in nature. Now we are going to study about the reaction with water. Now we are going to know about the reaction with water. The non-metals do not react with the non-metal. I have told you about the metals. The metals when react with water to form metal oxide and metal hydroxide plus hydrogen gas is formed. And I have told you about the reaction with cold water, reaction of the metal with boiling water, reaction of the metal with steam. I have told you that the reactive metals, that very reactive metal, just like that of sodium and potassium, they just react with cold water very rapidly and displace the hydrogen from the cold water at the room temperature. For example, sodium when reacts with water to form sodium hydroxide and the hydrogen gas is formed. So just like that of, we have studied that reaction with steam. I have told you that less reactive metal like iron and nickel, that iron and nickel displace the hydrogen gas from the steam and forming the oxides of metal. For example, iron when reacts with water, it forms iron oxide plus hydrogen gas is formed. Non-metals when kept in water, the non-metals do not react. There is no reaction of the non-metals with water. Non-metals do not react with water. In fact, here also there is one case that in order to protect it from the influence of air, for example, if the phosphorus is kept in air, it catches the fire very rapidly. So that's why it is kept in water. Phosphorus is very reactive to air. When it is kept in air, it gets react with oxygen and it catches the fire. So that it is kept in water because it is a non-metal and it do not react with water. Now we are going to study about the reaction with acid. Yesterday we have studied that metals reaction with acid, then there is a formation of salt and hydrogen gas. For example, when zinc reacts with hydrochloric acid, there is formation of zinc chloride, there is salt plus hydrogen gas is formed. And here in case of non-metals, the non-metals generally they do not react with acid. There is no reaction of the non-metals with acid. They do not react with acid. Next is about the reaction with bases. Now reaction with bases, we have studied that most of the metals do not react with bases, but there are some cases like that of aluminum, zinc and lead that react with the solution of strong base like sodium hydroxide to produce the salt of that metal plus hydrogen gas. But here in case of non-metals, the non-metals react with bases. The reaction of the non-metals with the bases is very complex in nature. That we will study about that in your higher classes. Now the next topic of this chapter is displacement reaction. Now we are going to know about that. What is displacement reaction? This is a type of reaction in which the most reactive metal displaces the less reactive metal from its salt solution. Just take the example of copper sulfate. When copper sulfate reacts with iron, we are knowing that iron is more reactive than copper, so that iron displaces that copper from its solution. So there is a formation of iron sulfate. Plus copper is displaced from its position, and this type of reaction is known as displacement reaction. There is another example also. We can take the example of the displacement reaction of the silver nitrate solution by the copper metal is another example of the displacement reaction. So this is about the displacement reaction. So what is displacement reaction? The reaction in which the more reactive metal displaces the less reactive metal from its salt solution, and this reaction is known as displacement reaction. As I have told you the one example in which we have taken the copper sulfate solution and we have taken the iron. When the copper sulfate reaction with iron is more reactive than copper, so that iron displaces the copper from its solution. So there is a formation of iron sulfate plus copper is displaced from its position, and this type of reaction is known as displacement reaction. Now we are going to study about the next topic, that is about the reactivity series. So first of all, we know that what is reactivity series. This is a kind of series in which the metals are arranged in a vertical column in the decreasing order of their reactivity. It means that the most reactive metal is placed at the top and the least reactive metal is placed at the bottom. Now they can arrange like this. They are arranged in a vertical column in which the top position is of most reactive metal and the bottom position is of least reactive metal. Here there is one reactivity series is given to you, and this reactivity series shows that potassium is the most reactive metal and gold is the least reactive metal. So after that potassium there is a sodium. So sodium is less reactive than potassium. Then after there is the position of calcium. Calcium is less reactive than sodium. Magnesium is less reactive than calcium. Aluminum is less reactive than magnesium. Zinc is less reactive than aluminum. Iron is less reactive than zinc. Tin is less reactive than iron. Lead is less reactive than tin. And hydrogen is placed at the middle, and after that copper. Then after there is a place of mercury, then after there is a place of silver, and gold is at the bottom. So this kind of series, this kind of arrangement of the metals in the order of their decreasing reactivity is known as reactivity series of the metals. So this is about the reactivity series of the metals. Next is about, there is one chart is given to you, and this chart shows that the physical properties of the metals and the chemical properties of the non-metals. Now let us recap all the things that we have already studied about the metals and non-metals. I have told you the physical properties of the non-metals. I have told you the physical properties of the non-metals and the chemical properties of the non-metals. Now just remind all these points again. First is the physical properties of non-metals. So non-metals are non-malleable. Non-malleable means they cannot be beaten into thin sheets. Second is they are non-ductile, so that we cannot draw the non-metals into thin wires. They are poor conductor of heat and electricity. It means that they do not allow the heat and electricity to pass through it. There is one exception only. The exceptional case is graphite. Graphite is only the non-metals that allow the electricity to pass through it, and they can be solid, liquid or gaseous state at the room temperature. Means they are found in all the three states. They are found in solid state also, they are found in liquid state also, and they are found in gaseous state also. So this is about the physical property of the non-metals. Now next is about the chemical properties. The chemical property, in which the first one is they are generally electronegative, means they form the negative ions by gaining the electrons. Loss of electron means formation of positive charge. The metals are electropositive while the non-metals are electronegative. Gain of electron means formation of negative charge. Next, they do not react with water. There is no reaction of the non-metals with water. I have given you one example of the phosphorus. That phosphorus is generally kept in water because they do not react with water. In order to protect it from the influence of air, they are generally kept in water because the phosphorus is a non-metal which do not react with water. Next is they form the ionic compounds with metals. So when they react with metals, they generally form the ionic compound. For example, sodium chloride. The formula of sodium chloride is NaCl, and in which sodium is what? Sodium is metal and chlorine is what? Non-metal. So when they react with each other, there is a formation of compound. That compound is sodium chloride NaCl, and that compound, in which the sodium having the positive ion and the chlorine having the negative ion. So this type of compound that is formed by the reaction of metal and non-metal is, what is the nature of that compound? They are ionic in nature, and that compound is known as the ionic compound. So ionic compound is formed by this method. Next is here there are some questions that is related to the topics that I have taught you in this chapter. So there are 5 questions is given to you, and I have to write their answers in your assignment copy. So read all the questions properly and write their proper answer in yours. So please do this work in your assignment copy. So write all the answers in your assignment copies. Next is about the uses of metals and non-metals. Now we are going to know about that, where these metals and non-metals are used. So one by one we will know that where the metals are used and where the non-metals are used. The metals generally like copper and aluminum, that is used to make the electric wires, because these are the ductile metals, and they are malleable also. They are used to make the cooking vessels. Next is about the iron and steel. Iron and steel are the metals that is used to make the machinery, automobiles, boilers, bridges and buildings. Stainless steel, we are generally using the cooking utensils that is made up of stainless steel, and they are also used for making the surgical instruments, because that is stainless steel, they do not get corroded. So that's why they are used for making, there is no rust formation on it, so that's why they are used for making the surgical instruments. Next uses that I have told you that mercury is only the metal that is found in liquid state at the room temperature, and that mercury is used in thermometers. Gold and silver are mainly used for making the ornaments. Aluminum is extensively used for making the aeroplanes and automobile engines. So tin is used for coating of iron containers for packaging, because tin is a non-reactive metal, so they do not react with air. So that's why they are mainly used for coating on the iron containers for packaging the food. Now next is about the uses of the non-metals. So non-metals such as nitrogen is used for making the fertilizers. As we have known that nitrogen is very important for the growth of the plants. Nitrogen is important for the plants to synthesize the proteins. So that non-metal like nitrogen that is used for making the fertilizers that enhance the growth of the plants. The non-metals such as chlorine is used for the purification process. Purification, they are used to kill the germs present in water. They are used for the purification of the water. Next is about the non-metals such as sulfur and phosphorus. They are used for making the crackers. So these are the examples of certain metals and non-metals that is used for the different purposes. So this is the last topic of this chapter. I hope that you all have understood all the topics that I have taught you today, and there are 5 questions that is related to the topics that I have told you in this chapter is given to you as a homework to do in your assignment copy. So you must do all the questions properly, write their answers in your assignment copy. I hope that you all are able to do all the questions very easily. So students, please do that work in your assignment copy. Okay students, thank you.